Hello and welcome back to Coach Quant. Today we're going to be looking at a problem about a three-legged table. Imagine you have a perfectly circular table and you randomly attach three legs to its underside. Each leg is fixed firmly and stands perfectly perpendicular to the surface of the table. If you flip the table over and set it on its legs, what is the probability that the table will stand stably without tipping over? So the best way to do this is to look at it conceptually. So let's draw out the table. And let's imagine we choose 3 points for legs, here, here, and here. Now, the legs are spaced out apart quite well, so this table won't fall over. The center of mass of the table is included. It's in the middle of these 3 points. However, we know that if we change the location of, say, one of these legs to the right side of the table, over here, the center of mass is well outside of the area supported by these three legs. And so the table will fall over to the left. And so we want to find the right place to put all three of these points such that the table doesn't fall over. So what we're going to do with this problem is actually find the probability that the table will fall over and then take the complement to find the probability the table will not. And so what is the orientation of table legs such that this table will fall over? Well, certainly we need the center of mass to be within the bounds of the three legs. So what that means is we actually want these three legs to be less than 180 degrees apart. So 180-degree arc. We want it to be less than 180 degrees. And that will ensure that the center of mass is outside of the support area for these three legs. And so the question becomes, how do we choose three legs that are within 180 degrees of each other? What's the probability that we do such a configuration? Well, let's start off by picking one table leg. Doesn't matter. It won't determine whether the table will fall over. And then pick a second one. So we have 1 and 2, randomly chosen. We need to know where the third one will go before we can figure out the probability. And so let's analyze, given this placement of 1 and 2, what placement of 3 will cause the table to fall over? Well, as long as the next point is within 180 degrees of 1 and 2, the table will fall over. So if we put the point here, or here, or here, or here, or here, the table will absolutely fall over. But if we place it outside of 180 degrees, so over here, the table will certainly fall over. So we really want the table to be within these dotted lines here. As long as the third leg is within the dotted lines created. So as long as it's over here, 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 all these locations are fine because they are within 180 degrees of 1 and 2. And so the question becomes, how do we compute the probability of such a setup of three legs? Well, we're going to do this by first finding the angle between 1 and 2. Let's call it A. We want the point, the third point, to be placed such that the angle A and the angle B, which we'll just call the angle between the third point and either points 1 or 2, we want A plus B to be less than 180 degrees. And so what we really want to calculate this probability, what we really want is for this third point to be such that a plus b is less than half the total angle of the circle. So the way we calculate this is by doing the following. We know that the angle A, the angle that's allowed for the point to fall is equal to the sum of these three parts. The angle A plus the angle 180 degrees minus A over here, plus the angle of 180 degrees minus A over there. And so as long as our point falls within one of these three areas, we're good. The table will fall over. So the question becomes, what's the probability of falling in one of these three areas? Well, all we have to do is take this sum and divide by the total area of the circle, 360 degrees. And so this just becomes a simple math problem. It's 360 degrees. Simplify the numerator. It's 360 minus a over 360, which is also equal to 1 minus a over 360. So this is the probability that the table does fall over. So the probability that it doesn't fall over is just the complement of this. So the probability of it standing is equal to the complement. The probability of it falling is equal to 1 minus 1 minus a over 360 is equal to a over 360. Now we know that a can take on any value between 0 and 180. And we know that a is evenly distributed between 0 and 180, right? So the maximum distance between any 2 points on a circle is 180. So if we choose two random points around a circle, the chance that it's at any point between 0 and 180 is the same. And so the reality is the probability of getting a certain a value, right? If we look at the distribution of P of A, will just be 1 over 180 for the distance of 0 to 180. And so to compute the probability that the table falls over, we have to integrate over all of A from 0 to 180 of the probability we previously calculated multiplied by the distribution of A. Now we know the distribution of A is 1 over 180 for all A, so that's just a constant. And the probability is A over 360, so we just plug this in and we get 1 over 180 times A over 360, which integrates to 1 over 360 squared times A squared. And we plug in our bounds of integration, which just gives us 1/4. And so that's it. That's the final answer. Now, this was a medium level problem, and we have plenty of other problems on our website at coachquant.com from many, many other firms, including Jane Street, Citadel, uh, Goldman Sachs, and many, many more. I encourage you to go check out those problems. We have answers and solutions as well as hints. So please go check it out. It's easy to sign up. We offer all of them for free. That's coachquant.com. Thank you very much.